Alright, we continue our series on horizontal asymptotes. This is part 2. Let's remember our definition of a horizontal asymptote. The line y equals k is a horizontal asymptote for my function f if f of x approaches k as x approaches plus or minus infinity. Now we learned also in our first video that the particular function f of x equals 1 over x has y equals 0 as a horizontal asymptote. And what that means is that as x approaches infinity, f of x approaches 0. And we also discovered as x approached negative infinity, f of x approached 0. Now, the way we illustrated this was by plotting a bunch of points and noticing a trend. Using that same line of reasoning, we would discover that f of x equals 1 over x to some integer power where n is greater than 1 produces the same, y equals 0 as a horizontal asymptote. We also could see that f of x equals a constant times x to the n, where n is larger than 1. Y equals 0 produces a horizontal asymptote. And so what all that means is that as x approaches plus or minus infinity, in all of these cases, f of x approaches 0. And we're going to use that in this video and in the following videos to construct the three possibilities that rational functions can take in terms of their asymptotes. Okay, so let's look at a particular example. Well, let's look at the possibilities that our rational functions can take. Recall that a rational function equals p over x, p of x over q of x, where p and q are polynomial functions. Now, the degree of a polynomial function is the highest power of the polynomial. So, for example, 2x to the 5th minus x to the 4th plus x cubed minus 2x plus 1, this polynomial has degree 5 because 5 is the highest power represented. Okay? So, there are three possibilities for a rational function in terms of their degrees. First is the degree of the top is smaller than the degree of the bottom. The second, the degree on the top is equal to the degree on the bottom. And the last, the degree on the top is, you guessed it, greater than the degree on the bottom. And each one of these cases produces a different horizontal asymptote or lack thereof. Alright, in our next video we'll explore the case where the degree on the top is smaller than the degree on the bottom.